Hello, welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based in Europe, and I'm going to be hosting this session today. And we're back on the journey through the cloud today for social and mobile apps, taking a look at how you can develop and operate mobile applications on the AWS cloud. Before we get started with the content, just want to let you know that you can download the materials from today's webinar in the Files panel in the webinar interface. Those will be in PDF format there. And there's also a link to a slide share that contains the presentation materials from today's session in the webinar description, the video description, if you're watching this on YouTube on demand. Other things that you can see in the live interface, a Q&A panel where you can ask questions of our team. We'll try and answer as many of those as possible at the end of today's session. And any that we can't cover, we'll come back to in email over the course of the next week or so. You can also see a links panel in the webinar interface, which contains some AWS social media accounts and also some other URLs that you might find useful in order to learn more about the content that we're going to be covering during the session today. And at the very end of the session, we're going to switch the webinar interface into Q&A mode. Once we've done that, you'll see an additional panel appear. And in that panel, you can give us a rating from 1 to 5, with 5 being the best. We'd love to get your feedback on how we've done today, either in giving us a score or even better than that. If you can spare a couple of minutes to leave us some feedback in the form of a question, some qualitative feedback, that would also be really helpful for us, help us optimize and tune this webinar to make it as good as we can for future audiences that might attend it. The last thing to say is we have another webinar series also presented in conjunction with Intel, as is today's session. The other webinar series is called the Masterclass series. You can find a link to that again in the links panel that you can see in the webinar interface. In the Masterclass series, we're diving deep into specific AWS services. And if you're interested in learning more about some of the services that we touch on today, you might want to check out that Masterclass series page. There's both on-demand webinars that we've already recorded there, as well as the rest of the program set out for 2015. So join us for the Masterclass, also presented in conjunction with Intel, if you're interested in learning more about specific AWS services in a deep dive. But as I said, today it's the journey through the cloud, a solutions-orientated look at building social and mobile apps on the AWS cloud. And in this particular series, we're looking at common use cases and adoption models for AWS, hopefully helping you learn from the journeys taken by other AWS customers and talking to you to help you discover best practices that you can use to bootstrap your projects. And we're talking today, as we've said several times already, about building social and mobile apps on the AWS cloud. And the real benefits of doing this, it enables you to create applications quickly and easily. And AWS will manage your application backend for you, provisioning, scaling, and monitoring the server platform that delivers the services that you can then take advantage of within your application. And you can access a wide range of services that can help you speed up app development. Those are the sort of high-level benefits of using the AWS cloud to deliver the backend for your mobile apps. And the agenda that we're going to take a look at today, we'll dive a little bit more into why you might use AWS for mobile app development. We'll then take a look at the AWS mobile SDK and connectors, Amazon Cognito, an identity and authorization service for mobile applications. We'll talk about serverless mobile backends, user behavior analysis, mobile push, storing and sharing media with Amazon S3. So that's integrating another AWS service together with mobile apps. And then lastly, we'll show you, as usual, a few resources that you can use to learn more about developing mobile applications in the AWS cloud. So why develop mobile apps on AWS? And the first thing to say is we've got broad adoption actually of AWS as a target platform for the development, deployment and operation of mobile applications across both enterprise customers like NTT Docomo that you can see here, and actually a variety of other enterprise customers as well. And then into the startups and pure play mobile app space with customers like Wunderlist, Supercell, Easy Taxi and others who have developed very successful mobile applications using AWS as a development, deployment and operating platform for those apps. And there's a very good reason for that. That reason is that mobile developers spend much of their time building features and functionality that's already been developed by others. If you take a look at these common application features, common application functions that are present in many mobile apps today, you'll see that they're all things that many developers spend time building, whether that's authentication, managing user identity, and enabling you to provide service access for particular users in a secure and reliable manner using those authenticated identities, whether that's synchronizing data across different devices, whether it's pushing notifications to mobile devices to drive repeated or increased user engagement, or maybe it's analyzing application usage and tracking the retention of users, or streaming data from devices in real time. These are all core components that many developers spend time developing, when in reality, and this is what we've heard actually from speaking to mobile developers, the majority of those functions, those features, they don't actually add that much to the user experience, and developers spend their time on this undifferentiated heavy lifting building these platform functions when they should really be spending their time focusing on the core differentiating features within their app and the core user experience that their specific application offers to their customers. And what we're trying to do really with AWS mobile services is take on that undifferentiated heavy lifting on behalf of customers and help solve some of the problems that mobile developers face today: platform fragmentation, scaling and developing things like sync functionality or mobile push functionality, reducing the costs of operations and making the startup costs, particularly of getting started with deployment of a mobile app, much lower, and also simplifying the startup experience so that mobile app developers can quickly deliver functionality which is core to their application, securing the knowledge really that these platform features, the platform features that you can see there on the left hand side of this slide, are going to be delivered in a way which is scalable, reliable, secure and cost effective. And what we've done really to try and help customers achieve this outcome is develop a suite of mobile optimized services, which we introduced actually last year at the AWS Summit in New York, actually an event that's just about to come up again, where we released a set of new services: Amazon Cognito, Amazon Mobile Analytics, enhancing Amazon SNS Mobile Push, to deliver platform services for mobile developers that can help them tackle some of the challenges that we talked about a second ago. Services which can help them deal with things like user identity and data synchronization, with cross-platform analytics and reporting, with cross-platform push notifications. Recently we added to this a service called AWS Lambda, which is intended to enable mobile developers to run functions in the AWS cloud, functions which today can be written in JavaScript or in Java, initiated by API actions from our mobile SDKs, but executing this code in runtime which resides on resources provided by AWS. So that's decoupled application architectures where your backend can be delivered in an elastic and scalable fashion without you having to provision servers or worry about infrastructure in any sense. And we've also delivered integrations with a variety of other AWS services like Amazon Kinesis, Amazon DynamoDB, Amazon S3, SQS and SES, to enable you to integrate mobile applications with other back-end services provided by AWS. So for example, to easily and quickly and reliably upload and download media or other assets to S3, integrating that with mobile applications so that you have access to reliable and durable and extremely scalable storage that you can integrate with your applications using a pre-existing AWS service, Amazon S3, and integrating that with an S3 transfer manager component which is designed specifically for mobile. We'll come to that and talk about it in more detail later in today's session. So basically what we've done here is provided a set of services that enable you to tackle those core functionality requirements in mobile apps without you having to spend time and effort developing those yourself. You can instead take advantage of these AWS services and focus much more of your time on the core functionality that differentiates your applications from other apps that might be present in the respective marketplaces that you're going to be selling or distributing your applications through. Okay, so that's a little bit about why you might choose to develop and operate mobile applications in the AWS cloud. What about some of the platform components that we've talked about there? Let's go into a little bit more detail in those now and talk about some of the functions and features that you can use to develop and deploy mobile apps on the AWS platform. And the first is the AWS Mobile SDK and connectors. And we launched the first mobile SDKs for Amazon Web Services, as I said, last year. We've iterated on those actually quite a few times over the course of the last year, as well as launching additional SDKs. We just took the Unity SDK out of developer preview a couple of weeks ago. That's now generally available for use, and we'll talk a little bit more about that in a second, where you can get it and what the services are that are supported. But we've had support for Android and iOS for some time now, as well as Fire OS, JavaScript in browser SDK, and we've got a developer preview of an SDK for Xamarin, which is still running at the moment. Again, another cross-platform development toolkit. And these are native SDKs that optimize specifically for execution operation on mobile operating systems. So they'll use things like, for example, local offline caching architectures. They're optimized to minimize footprint, enable you actually to pick the service jars or other components that you might need to support the specific functionality that you need for your app. So once again, you can minimize the footprint of your application, both in terms of the amount of content that users may need to download in order to execute your app, but also in terms of the memory footprint for your application once it's running on the mobile device. And these are very actively maintained kits, which are constantly updated with the latest platform enhancements. One example, as I said a second ago, is the AWS Mobile SDK for Unity, something that we just brought out of developer preview and made generally available. You can find this on the AWS GitHub using the URL that you can see in the bottom right of your screen here. At the moment, we're supporting Cognito, DynamoDB, Mobile Analytics, SNS we just announced quite recently, and also we're supporting Amazon S3 for object storage as well. And as you can see in the screenshot that I've grabbed for you here from the GitHub repo for the Unity SDK, there's a full set of resources available. This is consistent actually across all of the different mobile SDKs. So you'll find off the GitHub repos for each SDK links to code samples, developer guides, API references, release notes, and also locations where you can report issues and submit pull requests if you wish to do that, to contribute towards the development of these SDKs. So check those all out on GitHub. You obviously, I guess, have a platform of preference that you prefer to work on. Take a look at the SDK for your platform of preference, and please provide us your feedback and let us know if you discover any issues or identify any improvements that you feel we could make. The second half of the picture here is mobile optimized connectors. These are present within the SDK. These enable you to work with other AWS services from within the mobile SDK for whatever platform you happen to be developing on. So it's things like the S3 Transfer Manager. This will enable you to do things like support multi-part upload, enable fault-tolerant downloads, automatic retries, provide pause, resume, and cancel functions. So you can see how we've optimized through the provision of a transfer manager, a connector to enable you to work directly with the S3 service within your mobile apps. Similarly, we've done something very similar for Kinesis, and for DynamoDB, we've provided both a mobile optimized connector and an ORM, an object relational mapper as well for DynamoDB. These allow you to make direct use of AWS backend services within your mobile applications. So for example, for DynamoDB, developing mobile games, you might store high scores directly into a DynamoDB table accessed across all the users of your particular game, all the players of a game that you might have developed and launched. And then you'll have a shared state database there, a shared state table that all the different users of your application can access in real time. No backend, no servers, just direct access to the DynamoDB API from within the AWS mobile SDK on whatever devices your application, your app happens to be running on. So it's a highly scalable, very, very secure and very, very low cost mechanism for delivering functionality in apps that completely removes the need for you to manage server infrastructure. The first service that we're going to look at in detail is Amazon Cognito, and this is a service that allows you to authenticate users and save app state settings. What we do here is provide a secure mechanism for storing data, make it available offline on mobile devices using functionality within the mobile SDK. We also provide a highly scalable and very reliable sync function to enable you to synchronize data sets across different devices, and those devices can be cross-platform, so you can synchronize a user's data across devices, Android to iOS, if you wish, or even across onto Unity. We're simplifying identity and access management, so we provide a function for managing users and unique identities across a variety of different identity providers, including Facebook, Google identities, login with Amazon, recently added support for Twitter, as you'll see in a second, and you can also use your own authentication. We're also providing an unauthenticated identity, which is a guest identity unique to each user that uses your app. This enables users to start using the application synchronization functionality without necessarily having an identity. And then if they subsequently identify themselves, we will manage the reconciliation of guest synchronization data into an authenticated identity from multiple devices if they've indeed accessed the application as a guest on multiple different devices. And then thirdly, it enables you to implement security best practices, and this allows you to use things like a unique Cognito identity ID as a token within, for example, S3 bucket access policies. So you could allow a customer, a user, to securely access data inside S3, whether authenticated or acting on an unauthenticated identity. And the expansion of their user ID would restrict which objects within S3 they were able to access. This enables you to implement security best practice and a principle of least privilege. Talking briefly about identity in a little bit more detail, as I said a second ago, we support multiple login providers here, so you can easily integrate with major login providers for authentication. Twitter, we added support for that quite recently in April, but we've had Facebook, Google+, login with Amazon, and the ability to use your own identity provider, as well as OpenID Connect, for quite some time now. We're providing a mechanism for managing unique users versus devices, so we can automatically recognize unique users across devices and platforms using those different identity providers. As I said a second ago, we can reconcile sync operations using the Cloud Sync and Save functionality, which I'll talk about in a second. Even if a user starts unauthenticated, when they subsequently provide an authenticated ID, we'll reconcile that sync operation, merging those sets together. And this, as I said, also enables you to implement security best practice to enable you to securely access any AWS service from a mobile device using things like identity IDs as expansion tokens in access policies. That's a very, very powerful feature. Beyond the scope of this webinar, really, to go into a lot of detail, but if you check the service documentation for Amazon Cognito, you can find out a lot more about that. Sync and save functionality. So this is enabling you to store app data preferences and state across a variety of different devices, across a variety of different platforms, so cross-device and cross-OS sync. It enables you to work offline with the local cache, which is stored in a local SQL-like DB on device, so it can work seamlessly when there's intermittent or no connectivity, and sync changes will be reconciled when connectivity is available again. And there's no backend here. This is client SDK, simple client SDK code communicating directly with the Cognito API endpoint, and you don't need to run servers or run any infrastructure to take advantage of this functionality. Integrating it into an application is very simple. There's some code samples here for development on the Android platform. Basically, you will initialize a new credentials provider using the new Cognito caching credentials provider creation function, and that will give you then a Cognito provider object which you can create a sync manager on. You can then create and open a data set and add key values to that, and you can call synchronize on that data set, and that is basically it. Your data set will be pushed then to the synchronization service, and it'll be available on other devices that you use the same ID on. It's that simple. So you really don't need to do a lot on the client development side of things to take advantage of this functionality. Next thing to talk about is serverless mobile backends, and this makes use of a relatively new AWS service called AWS Lambda. We announced this at AWS reInvent in Las Vegas last November. This enables you to run stateless functions in the cloud and scale those, once again, without having any servers to manage. We started with JavaScript support, which was for asynchronous functions, but we recently added synchronous function capability for invoking Lambda functions from within the AWS mobile SDK. It It enables you to focus on business logic. You really don't have to worry about infrastructure. You just upload the code that you want to execute in response to your function calls, and AWS Lambda will provision and scale an execution environment for that code for you without you having to worry about deploying or scaling EC2 instances or any other infrastructure components. At the moment, we support JavaScript and Java, as I've said, but there are community contributed wrappers to enable you to execute code in other languages. And you can do anything really that you can do in JavaScript in Lambda, creating threads and processes, running batch scripts, and also running other statically compiled executables or executables that might be available on the EC2 instances that do execute these Lambda functions. And there's full documentation of the packages, binaries, and configuration details of the execution environment available on the Lambda product detail page in the documentation section, which I'll show you a link to at the end of the session. We found that customers have put Lambda to a broad range of use cases. Obviously, we're talking here primarily about server-free backends for mobile applications. But you can actually use Lambda for any application type that can benefit from event-based computing. That might be data triggers for ETL. It might be IoT-style applications, which is actually a form of mobile application in many respects, stream processing, or index and synchronization. Just to try and make this a little bit more tangible for you, if this is a new concept for you, here's an example of a serverless backend for a mobile app. So imagine a situation where you've got a social application incorporating photos. You can have your mobile SDK triggered when a user chooses to take a picture, store an image on their mobile device. And using that, you can process, filter, or transcode those mobile images. So what we're doing here is invoking a Lambda function when a user uploads a photograph. We're synchronizing a data set there. We're placing a record into a DynamoDB table. We're executing a processing job on that particular image that's been uploaded using the S3 transfer manager. We're then pushing back an SNS push notification to the mobile device, and we're informing the user that their photo is available to view, and that photo could have been pushed in a filter, Instagram style or other filter, applied to that photograph asynchronously using processing resources delivered using Lambda. So very, very powerful function, very, very powerful feature rather, that enables you to scale this compute resource pool very, very simply without you having to worry about provisioning infrastructure, as I've said several times already. Next thing I want to do is take a look at some examples of how you can integrate AWS Lambda with your mobile applications. And the first option that you've got is to use synchronous events. So this is a mechanism for enabling you to respond in real time. For example, if you might want to process a data check or retrieve results or data and present these back to your mobile application, you can use a synchronous call for that, enabling you to do that in real time. You can also, of course, use asynchronous calls. That photo style application that I talked about a second ago is more likely to be built around those asynchronous call flows. The second opportunity that you've got is to do function mapping. So you can map local functions to cloud functions directly within the mobile SDK. And I'll show an example of how to do that, a code sample of how to do that in a second. Thirdly, you can integrate Lambda with SNS, so the Amazon Simple Notification Service. This can enable you to do things like target, filter, and route Amazon SNS notifications, for example, to customize an SNS to a particular user, something that you could do using Lambda and SNS integration. Similarly, there is integration with Cognito, and this Cognito integration is quite interesting. If a user has authenticated themselves using one of those public logon providers that we talked about a few minutes ago, that user identity is then automatically and securely presented to your Lambda function in the form of the user's Amazon Cognito ID. And that can enable your Lambda function to access user data from within Cognito. So for example, to access the key value store that's present there, or to access data directly within DynamoDB or another AWS web service, which might be protected using that Amazon Cognito ID. So your Lambda function can act with the same identity as your mobile application. This can enable you to do things like apply custom logic to user preferences or game state, or read information from user preferences or game state before executing actions within the Lambda function. I think you can imagine that's a very powerful feature. And there's also other options that you've got as well. Obviously, I mentioned before Java support, integration with AWS CloudTrail, and enhanced logging and metrics via CloudWatch. So you have full integration with the AWS auditing and control and metrics packages as well. You can find out a whole lot more about those examples that I just talked about, as well as a lot of other information about Lambda if you check out the frequently asked questions, awsamazon.com/lambda/FAQs. That's a very, very good resource for finding out more about how you can make use of AWS Lambda in your mobile apps. This idea of function mapping is a particularly powerful feature. You can see with these code samples that it's very simple to set up, initializing the Lambda factory and defining the interface for the functions that you want to map to Lambda functions. Then you create or upload the Lambda function to the AWS Management Console. Of course, you can do that on the CLI if you wish, or you can do it via the AWS GUI, the AWS Management Console. And then when you call local function, the function object that you defined in step 1, that will execute the remote Lambda function. Very, very simple. And that enables you to embed and integrate Lambda resources within your mobile applications very, very simply. So that's serverless backends. Analyzing user behavior. And this is another service that we launched at the AWS Summit in New York last year. And we're talking there about making it easier for mobile developers to collect and analyze application usage data. And we launched a service called Amazon Mobile Analytics for this. It provides a reporting dashboard very, very quickly to enable you to access data within 60 minutes of receiving it from an app. It's a very generous free tier, which we'll give more details on at the end of today's session. And you have and retain ownership of your data. Data is not shared, aggregated, or reused by AWS for any purpose. It's your data made available to you in the Amazon Mobile Analytics dashboard. And if you visit the AWS console and take a look at Amazon Mobile Analytics, you'll find a getting started guide there as well as a product demo. This is what you'll see if you don't have any mobile analytics workflows set up or connections set up on your account. You'll be presented with this console page the first time you visit the console. And from there you can take a look at examples of the reports that you can get if you try the product demo, and you'll see a screen that looks a little bit like this if you do that. With just one line of code in your app, you can get access to metrics such as your monthly active users, daily active users, new users of your app, daily sessions, and other data as well. It's very, very simple to access that, and I'll show you a code sample in a couple of slides' time that shows you how to enable this standard reporting. You also have the option and opportunity to track custom events, which can enable you to get behavioral insights into app-specific actions that your users might take. These will be presented to you in the same analytics console as the stock or standard metrics. But you can use triggers, for example, to understand player abort rates per level if you're developing a mobile game, or understand the number of songs played per user per session if you had a mobile music app, for example. And it's very, very easy to integrate these custom events. Setting up the stock events is as simple as just initializing the Mobile Analytics Manager object, and that'll give you session activity in the AWS console within 60 minutes of the activity taking place. You can also resume and pause analytics recording sessions, as you can see there. And you can add those custom events very easily too, using a custom event object that you can create using code similar to the third sample that you can see on the screen here. Once you have your data inside Amazon Mobile Analytics, you can make use of that with a variety of reporting tools. It's very common for customers to export that data to S3 and then load it into a Redshift data warehouse, our petabyte scale data warehousing service. And you can apply a variety of third-party ecosystem tools to analysis there, many of which are available in the AWS Marketplace. And I would encourage you to check out the AWS Marketplace if you're interested in running analytics tools. There's lots and lots of different options there available with hourly licensing in the same way as the resources are that you need to run them on in the AWS platform. Of course, once you've got your data in S3, you've got other options as well. You could archive it into Amazon Glacier if you want to keep it for long-term purposes for some reason. Or you could load that data into a Hadoop cluster using either traditional MapReduce or the Spark engine and process your data there. So you've got a few different options. We provide a managed service for export to Redshift within the Amazon Mobile Analytics console. So if Redshift is indeed the target that you have in mind, then take a look at that managed service. There's a very simple process for doing that, which is detailed on the Amazon Mobile Analytics product detail page. Next thing we'll take a look at is mobile push notifications. And this is a classic example really of a mobile app platform service that is common across a vast range of different mobile applications. It's actually something that it's very difficult to do well, both to do at scale and also to maintain and add support for the broad variety of different notification targets that you need if you're going to deliver an application, deliver a mobile app across a variety of different platforms. And what Amazon SNS Mobile Push does is it abstracts that away from you. So we deal with the heavy lifting of integrating with new notification providers and with scaling the platform for the delivery of messages at very high volumes. We have customers delivering hundreds of millions of messages a month using SNS Mobile Push, and more actually in some cases. And that's done without worry really by the customers, just submitting the notifications that they wish to push out to mobile devices into our API, and then we'll deliver them for them. It costs $1 per million SNS push notifications. It's a very, very cost-effective service. You could deliver 500 million notifications for $500. It's really not expensive to make use of this service. Again, there's much more detail on this on the product detail page. We recently added support for macOS push notifications. So you're now able to send push notifications to macOS desktops as well as to iOS devices. That's a very recent addition. Find out more about that on the mobile services product detail page. Wanted to talk briefly about sharing and storing media with Amazon S3. This is one example of integrating mobile applications with an AWS backend service, in this case the Amazon Simple Storage Service. You'll be aware of this, I'm sure, as a highly durable, highly scalable and very reliable storage service, object storage service. It's been around since 2006, and it's a service that's used by a wide range of different customers for a huge variety of different use cases. We provide an Amazon S3 connector in the mobile SDK, which is a transfer manager. This enables you to take advantage of Amazon S3 multi-part upload to deal with intermittent connectivity in the form of a fault-tolerant download capability. Again, it's a service that doesn't require a back end, so the mobile SDK talks directly to the Amazon S3 API endpoints in the regions that you specify. And your mobile app will work directly with the API endpoint. There is no need for you to provision or manage any server infrastructure to do that. We also deal with automatic retries, pause, resume, and cancel, and each implementation is optimized for the native OS that it runs on. On Android, here are some code samples showing how you can use this. You're just creating a new instance of the transfer manager object. And once you've done that, you can take advantage of that instance to upload and download objects by creating instances of upload and download. And then you're going to specify a bucket name that you're going to be dealing with, the file name, which will be local on your device, and the object name that you want to use remote. And that will result in the creation of an upload session, and similarly for download sessions. And then you've also got this pause and resume functionality as well. But we deal with connectivity intermissions that might result as a result of you running your app on a device that has less than perfect connectivity. That's a feature of the transfer manager to make sure that the heavy lifting of dealing with making connections and transfers reliable is something that you do not have to deal with. Okay, so that pretty much concludes the content for today's session. We're taking a quick tour there around different aspects of the AWS mobile services portfolio. Just quickly summarizing, we're providing a serverless infrastructure here which scales automatically to deal with the demand that you might have, whether that's 100 users for your application or 100 million. We will elastically scale the backend services that you're making use of to deal with however much usage you happen to have at any particular point in time. The services are flexible and they're integrated. So Cognito, for example, acting as a identity and access management service, authorization service to enable your mobile app to work directly with other AWS services. And this fully integrated nature really does make it very easy to get started. Some examples of integrations that you might want to consider. Just mentioned Cognito there. Cognito for push synchronization, where you might send an SNS notification to initiate a synchronization activity. And we've already talked about analytics, exporting data to Amazon Redshift to enable you to gain analytics insights from application usage data. Also, there's opportunities for integrating Lambda, things like triggering Lambda on the basis of DynamoDB streams. This is a Lambda trigger that's initiated by an update to a specified DynamoDB table, which is passed information about the update in metadata and can then process that. So that would be an asynchronous processing model where you might update a DynamoDB table from within your app using a Cognito authenticated identity working with the DynamoDB endpoint, and then asynchronously take some action on that using AWS Lambda. Same on Kinesis, where you can trigger based on streams, and you can also trigger based on S3 puts. This would be a good example of usage in that mobile photo sharing application that we talked about as an example for Lambda. You could make the async component of that work just by using the transfer manager to upload your photographs into a particular S3 bucket or prefix, and then trigger a Lambda action each time that happened to initiate some asynchronous processing of those images. How about putting the particular filter that you want to have applied to the image in the object metadata when you do the upload? Lambda can read that, do the processing, and then use SNS to notify your device that that image has been transcoded for you. So very, very powerful if you couple together these services. And then several new integrations. SNS and Lambda, that's a new integration. Cognito and Lambda, triggering Lambda functions on the basis of sync events. And Cognito, you can now stream Cognito sync activities into Kinesis and obviously take action on those asynchronously as well. So a very powerful set of services if you consider the different options that you have for integrating them and getting them working together. Also got those mobile optimized connectors that we talked about a second ago. So S3, Kinesis and DynamoDB with the ORM, optimized for the native OS and enabling you to work directly with service endpoints from within your application on all of the supported SDKs without requiring this server-based backend. So again, it's mobile SDK talking directly to AWS service endpoints. A very scalable and cost-effective way to deliver the backend for your application. I hope we've shown you there that you can slot in AWS services to meet many of the foundational needs that you're going to have in mobile app development. And you can get started with these services for free. There's a very generous free tier on AWS mobile services. Lambda, you have 1 million free requests per month and 400,000 gigabyte seconds of compute time per month, free permanently. With Cognito, for the first 12 months, we provide 1 million synchronization actions per month and 10 gigabytes of storage within Amazon Cognito for storing sync data. Mobile analytics, you'll perpetually have 100 million events every month that you can analyze and gain insights from at no cost. And with SNS Mobile Push, you can perpetually push 1 million messages per month without charge. So it's possible to build and actually scale a mobile app to some extent on AWS without paying anything for the first year, and if in some cases not paying anything at any point if you limit your usage of Cognito and make use of other services that have a permanent free tier. If you want to find out more about the free tier, please check out awsamazon.com/free. You'll see a drop down there. I've selected the mobile drop down here. You can pull the services that you're interested in, looking at the free tier allowances for out of that drop down, and establish precisely what the limitations are, and also see all of the services that are available in the free tier. If you take a look at that page, it's a very helpful resource. Other resources that you might want to take a look at to learn more about the topics that we've covered today: awsamazon.com/mobile. That's the main page where you'll find information about all of the services that we've talked about today collected, as well as information about a lot of the customer references that I touched upon at the beginning of the session, and links to many of the other resources that I'm going to show you in just a second. We have a mobile developer blog at mobile.awsblog.com, where we provide actually pretty deep content about making use of AWS mobile services to achieve certain things in your development process, in your development lifecycle. Here's a recent post, for example, about using Amazon machine learning and Amazon mobile analytics to build predictive applications for your mobile app. It's a very recent post from the 30th of June. And you can see there on the right-hand side of this slide some of the other things that we've covered. We recently provided some further details about enhancements and changes to the iOS SDK in version 2.2.0. We talked about using Amazon Cognito and AWS Lambda to detect cheating. And we covered a lot of other topics as well, so I'd like to encourage you to check that out. It's a really good source of information for mobile developers that want to make use of AWS, really a good resource. And here are some other resources that you might find useful. Find out more about the SDKs that I've talked about at awsamazon.com/mobile/SDK. You can follow AWS for mobile on Twitter, stay up to date with mobile service-related announcements. And of course, there's lots of information about Lambda, Kinesis, and Redshift on the product detail page for those respective services that you can see there on the lower 3 URLs on that page. If you're interested in AWS architecture more generally, then check out awsamazon.com/architecture. You'll find patterns there for many common applications. That might be a useful resource for you if you're new to architecture on the AWS platform. And if you're interested in building your AWS skills more generally, then please check out our training options. You can find full details at awsamazon.com/training. Many different options for training on AWS, associate and professional level training for architects and systems operations professionals, training for developers, and also a specialty course on big data analysis on the AWS platform, which might be useful if you're thinking about working with your mobile analytics data in Amazon's EMR, the Elastic MapReduce service, and using Hadoop for processing that data. You'll find out a good course for that at the Big Data Specialty course. Again, you can find that at awsamazon.com/training. Okay, that's all we have content-wise for today's session. I'm going to turn in a second and take a look at questions that have been submitted during the session today. If you do have any questions, please submit those using the Q&A panel that you can see in the webinar interface now. I'm going to ask my colleague to switch us over into Q&A mode now as well, so you can give us a rating between 1 and 5, with 5 being the best. Love to get your feedback on how you think we've done today. And if you've got any qualitative feedback you want to leave, as I said earlier, if you could leave that in the Q&A panel, we'll take feedback as well as questions via the Q&A. So let us know if there's anything you'd like us to focus on in more detail, anything you think we overdid during today's session. Please let us know. We can improve this webinar for future audiences if you're kind enough to do that for us. You can find me on social media at Ian with 4 M's. You can find AWS here in the UK and Ireland at AWS_UKI. That's really good for other webinars, by the way, and other in-person events and news here in the UK and Ireland. And if you want to stay up to date with AWS globally, find us at AWS Cloud on Twitter. You can find all the latest AWS service announcements and global news about new AWS services at AWS Cloud on Twitter. Okay, before we take questions, I just want to thank you, as usual, for joining us today. Really appreciate you spending time to learn a little bit more about AWS. It's great that you're willing to invest your time and learn more about the services that we provide. I'd like to thank you for that. And now we're going to turn and take a few questions. Thank you.